Good evening and welcome. This marks the 122nd episode of Nuclear Physics and You. Tonight's segment will be approximately 5 hours, containing the discoveries of a certain Joseph John Thomson and Ernest Rutherford. Today we'll be comparing and contrasting the similarities and differences between these two nuclear physicists.
Now, beginning tonight, we are going to start with Mr. Rutherford. A certain J.J. Thomson. His real name was Joseph John Thomson. He was born in 1856 in Manchester, England. Now, in 1870, he was admitted into Owens College. The man was a genius. He won the Nobel Prize in 1906. As we had earlier stated, he was involved in nuclear chemistry. He invented or created gases through electricity. He was knighted in 1908 and later was elected into the Royal Society. Take it away there, Randall.
Thank you, Dr. Veach. Now, on another note, Mr. Rutherford was born in New Zealand and soon immigrated to Britain, where he attended Canterbury College and Cambridge University. His discoveries in science included discovering that X-rays ionize atoms, producing large quantities of electrically charged particles. He discovered X-rays could actually pass through walls, brick walls to be exact. Magnetic waves could pass through brick walls, and he also studied multiple properties of the magnetic fields. Now, his greatest achievement was the nuclear theory of the atom, saying that all of the positively charged particles of the atom and nearly all mass contained in a very small nucleus that looked somewhat like a solar system, with the nucleus on the inside and the electrons orbiting around. Now, later we will actually be comparing and contrasting these via diagram later in today's segment. He supported this idea with theoretical calculations, and this was known as the foundation for nuclear physics. Now we will adjourn to the chalkboard, where we will discuss the similarities and differences. After that, we will go to the lab with Dr. Krall and Dr. Aziz, where they will be showing the models of the atoms. Thank you very much. Now we will talk about the differences and similarities between Dr. Thomson and Dr. Rutherford. So if Dr. Veach would take it away with Thomson.
Now, Dr. Thomson, J.J. was a scientist of the highest quality. He invented his form of the atom, which is, as shown here, more of a circular instead of with the rings outside for the electrons. He had a
protons and neutrons
all in the inside, which then formed into what Dr. Rutherford.
Yes, indeed. Dr. Rutherford had a different idea for the atom. Excuse me, can our assistant bring the ladder?
Please.
Because I think we're going to need that.
There we go.
Thank you.
Smile for the folks.
Get out of here.
Okay.
Now, Dr. Rutherford had the atom like so, with the positive and neutral charges in the nucleus. As shown, he said that the mass and the positively charged particles were all centered in the nucleus. Now, if you see here, hold on, excuse me. If you see here, the electron clouds surrounded the nucleus right here with negatively charged particles around it. So now this was built off of this, which is the interesting part, because this model right here had positive and negatively charged particles in one nucleus. However, when he built off of this one, what happened was he put them all in the nucleus, and that, my friends, is where the mass was. That is where the positively charged particles were, and the electron clouds that surrounded it is where the negatively charged particles were, which is the crazy part. It's really, really interesting. It's really, really interesting. This formed the basis for nuclear physics. Ernest Rutherford was a genius. He knew exactly what he was talking about when he discovered this at Cambridge University. Ooh. Cambridge University, which is where he discovered this. This university right here is where he discovered this, and that formed the basis for nuclear physics. He was a genius. He knew exactly what he was talking about. Any questions? And now, we're going to go to Dr. Krall and Dr. Aziz in the
They're going to be discussing
in the
different
lab
models.
to do models, and
You did great.
let's go.
By the beginning of the 20th century, scientists knew of the existence of atoms, and that they were made up of protons, neutrons, and electrons. However, they did not know how the atom was configured. In Thomson's pudding model, he stated that neutrons, electrons, and protons were together in the atom in no specific formation.
Now, Rutherford tried to prove his theory by taking this famous gold foil experiment. First, he put a piece of gold foil, which is only a few atoms thick, and he an alpha particle to the gold foil. Well, when he fired it, it passed right through, proving that the atom was not some dense thing, and it was mostly open space. And it also caused him to think that the nucleus was positively charged, because the positively charged alpha particle reflected right off it and reflected against this detecting screen.
This proved Thomson's pudding theory of all subatomic particles being together in an ununiformed mass incorrect. Rutherford created his own atomic model, which stated that the majority of the atom's mass was together in a nucleus, which contained the protons and neutrons. Around the nucleus, the electrons orbited, as do the planets in the universe. Atomic models have constantly been changing throughout history and are subject to change in the future.
Don't need money, don't take fame, don't need no credit card to ride this train. It's strong and it's sudden and it's cruel sometimes, but it might just save your life. That's the power of love.
I did science!
That's interesting.